So let me start off and ask, how many folks in here consider themselves more on the development side? Excellent, excellent. You never know. Sometimes I give this presentation and it's kind of more on the security side. They probably won't get as much from it. So I'm glad that most of the folks in here are on the development side. I do want to start off with a small disclaimer because this is about security testing. None of this stuff should be used on systems that are not yours. There are some tools listed at the end that can be useful to attack various systems. So yeah, don't do it unless you have approval. As mentioned, I have been a developer for a while. Or I guess you didn't say that, but I'll say it. I started out as a developer, obviously from running the Dallas PHP user group. I began with PHP. A couple years ago, I decided to pivot more into a specific area of application security. And I'm a speaker predominantly at developer conferences, but more at security conferences lately. And I am a security advocate in the PHP community. There are very few of us, but we're getting the word out, and it's getting better. So, fingers crossed that continues. And now technically part of Cisco, so as of a couple months ago. So some of the stuff we'll cover, some of the basic concepts of application security, the top vulnerability types. This is not an OWASP top 10 talk, so don't worry about that. We're not going to get into all of those things, just some of them, because hopefully if I have enough time, I'm going to give some examples, some practical examples. And then finish up with some tools and techniques that you can use to kind of find these issues. Normally, this was given as a 3-hour tutorial, and so the examples I have were actually hands-on, so that the developers in the room could sit down and try to find these issues themselves. But I had to shorten it, obviously, for talk length. So, if you're interested in the full version of this, I can give you the application that I created that I'll show you, and you can go wild with it. It's not as full-featured as some of the, CTF stuff that they have. Obviously, it's not a comprehensive guide to penetration testing. There's really not any way you can squeeze that into an hour, so hopefully nobody was expecting that coming here. That's a multi-day course, honestly. And this is not going to be an assurance that your application is completely secure. Obviously, there's no such thing as 100% secure. But this will give you a little bit of a better perspective, hopefully, on how you can test your application and find these kind of vulnerabilities in your own stuff. And it is definitely not a stopping place, so don't follow these slides and say, oh, I did all this stuff, that's great, my application's great. No, you're just getting started. All right, so some of the vulnerabilities. One of the most general classifications is an injection attack. Obviously, everybody's familiar with a lot of these. Is everybody relatively familiar with the OWASP top 10? I'm assuming if you're at this conference, you are. Okay, so all these should look pretty familiar. They're all different types of injection attacks. One of the ones that a lot of people forget is just regular old content injection. It's easy to highlight cross-site scripting and SQL injection and everything because they actually perform an action. But a lot of times content injection can be used to actually put things into the page, error messages, that kind of stuff, that misinforms the user and tells them to go do something else. It's not necessarily an action or something that happens because of it. It's just, general information. Cross-site scripting, the most classic example, the script alert in a parameter, URL parameter. And it's easy to forget that basically this can do anything that JavaScript can. This can modify page content, it can access cookies, local storage. I saw one attack that actually overwrote and knew that the images were on the page for a certain advertiser. And so the injection overwrote those with malicious links and images, but it looked like it was part of the normal page. So you wouldn't even know unless you knew that it was an actual attack happening. Fortunately, browsers are getting a little bit better about detecting that. They have some automatic stuff that happens. Usually it works best for reflective cross-site scripting, but those things, nothing's foolproof, so it's still possible to get attacked by them. So when you're working on an application, some of the places to look for the possibility of cross-site scripting, like if you're testing your own application, look for any form inputs where the data is just basically then output to the page. A lot of times this can happen in like a search field. You put a search term in and then at the top of the page it says you searched for whatever. Now if they're not properly escaping that, that's a pretty easy cross-site scripting vector to get in on. Sometimes you can also do the same thing with URL parameters. And don't forget about hidden inputs as well. In the forms, a lot of times the the ID or something like that from the URL will be taken and put into a hidden field. You can use that for an HTML attribute injection. You close off that quote, and then you can put in whatever you want to, including JavaScript and all that. So be sure and check the source of the page as well once you put that in there. And then sometimes, if they're not actually escaping it correctly, you can get stuff into the database, and that's then output on other pages, or like user profile information that could be output across the entire site. If there's not a consistent templating mechanism on there, then if they try to do it on every page individually, they might miss one. And if you have your name as script alert 1, then it'll show up on that particular page. So you just have to be careful. Obviously, the fix is filtering the output. That could be something as easy as a templating system. How many people actually use a generalized templating system on their applications? Okay, a couple of folks. All right, so do the rest of you just go in and escape your output manually on every single piece of data? Yes? No? This is yes. This is no. It's okay to say no. Or it's okay to say yes, I guess, in this case, as long as you're actually outputting or escaping that data and filtering it out. And then next up, pay attention to the context. There's actually several different contexts in web applications. HTML, JavaScript, CSS, HTML attribute, XML, and they all have to be escaped relatively differently. You can get away with some of the HTML stuff to escape that similarly, but if you're using user input and outputting it in any part of your application, any of those contexts, you have to be careful and escape it appropriately for the context. And like I mentioned, templating layers, they're a lot easier than one-off escaping. Coming from the PHP world, I have seen a lot of applications that use HTML special characters and those functions that escape the HTML constantly used throughout the entire application. And there's thousands of them in there. Now, obviously, the chances of you missing those are pretty high. You change one thing, and then you have to go through and be sure that that particular piece of data is escaped across the entire application. The benefit of having a templating layer, like in the PHP world, they have Twig, which is just one of the main ones. There's a lot of different ones, but that's the most widely used. It'll do the auto-escaping for you. So you pass the data into the templating layer, it manipulates it, and outputs the filtered version of it. Unfortunately, I haven't gotten to be able to convince them to take out the raw output type so that you can still output raw data without having it escaped, but maybe one day. Okay, next type of injection, SQL injection. Hopefully everybody's familiar with that. You close off that. You directly put stuff into the SQL statement that's being executed on the back end. There's a tool that I mentioned later on called SQL Map. Is anybody familiar with that? Okay, a couple of folks. For those that aren't, basically what it allows you to do is you define the parameter that's susceptible to the SQL injection attack, and then it can then use that to go in and basically extract anything it wants to. If you're doing manual SQL injections, manual attacks, and later on in one of the examples I actually show that. I'm not sure if I'll be able to get to it for this session. But you can use unions to extract anything. You can extract from the information schema, not just the database tables that you've defined in your application, but you can actually extract table structure, column type, all that kind of stuff. SQL Map makes that a lot easier. You just point it at the system and say, this particular parameter is vulnerable, and then it goes in and extracts all that stuff for you. And it's all automated and pretty and happy. It works for most things, but sometimes it has its quirks. And depending on what the queries are doing, you can actually perform SQL injection on update and delete queries. So you can potentially, say set this and then inject comma this, comma this, comma this, and update database information directly. Again, form inputs are a great place to look for SQL injection vulnerabilities if you're not filtering that. Any other querying functionality, the URL parameters, if you have a query parameter on there, that you could potentially do that directly without having to worry about, or having to check the post. Anybody sensing a theme here? User input issues? Okay, and URL parameters. Sometimes you can use these in blind SQL injection attacks. So you stick something in there that's purposefully made to slow the query down, and then it's vulnerable to an attack, even if you can't see directly some kind of change in the output. With this kind of thing, I mean, this is the usual example of a login bypass with SQL injection. But sometimes you want something, or you want to be able to tell if something's happening on the back end that's not necessarily reflected directly in an action being taken on the front end. So if you put in sleep statements or something like that, then you can see, oh, I can directly inject into the SQL. Let's see what else I can do with it, and start dropping tables or dropping databases and all that kind of fun stuff. So not super useful for extracting information, but if you want to just mess around and cause some damage, then that's always fun. So the main fix, obviously, for SQL injection is bound parameters and prepared statements. Is everybody familiar with what those are? Yes? Awesome. Good. Okay. You also have to be careful because sometimes that data that the user is inputting is used in other parts of the SQL statement. You can use these bound parameters and prepared statements like an aware clause, but if you're letting a user enter a piece of information that's a table name, that's a terrible idea. You know your table names. You should be able to specify those. I have seen, well, they're very seldom, but I have seen a couple of more management type applications that use user input for table names because they want it to be flexible, but that's just basically asking for trouble. So just be careful of that. Okay, next up, direct object reference. So the basics behind this is, well, there's kind of two different things. So you could have a direct object reference through, like if users upload files or something like that, they potentially, if they're web facing, are able to be referenced directly from a user just kind of guessing, file names or anything like that. And then there's also the idea of unprotected endpoints. If you log in and you're user /1, then it's a pretty good chance that if you change that value to 2 or 3 or 4 or 5, that if there's not good security controls in place, you're going to view somebody else's information and potentially impact it. Basically, if you find that kind of vulnerability in your app or you're using this kind of structure, be really careful and ensure doubly that whenever the page loads, that you're not just relying on the fact that they're on this URL. Go ahead and pull the user out of the session or however you're storing it, out of Redis or whatever. And then evaluate the credentials. That's a good thing to follow in general, honestly, is to go ahead and pull that user out and evaluate their credentials every time you possibly can. Don't just assume that because they've logged in and you have their permissions in the session, that those are going to be correct all the time. A lot of the better, more robust systems that I've seen, they'll actually pull that information, recreate the entire session every single time. I know it sounds expensive, but they recreate that session with the user permissions and everything every single time, so that if somebody on the administration side goes in and changes a value or changes a permission, that's instantly reflected in the application. If an attacker manages to get in with an account and the only time you're pulling the permissions is right at login, then you're going to have a really tough time, unless you have some way to manually end that user's session. Then basically they can just keep going forever and ever. And even if you change their permissions, it doesn't matter because they already have them from the login. Direct object references, look for URLs with auto-incrementing IDs. You could potentially change this and use UUIDs or some other kind of a hash-based kind of thing to reference these, so that basically it's a little more randomized. Now, obviously, you can still automate something that's a little more randomized even, but if it's just IDs, that's a pretty popular practice, is just using the primary key ID or some auto-increment ID from the database. Be very careful using that. You want to make it so that it's harder for the attacker to not just look at the page and say, oh, well, that's easy. I can just start incrementing these IDs. And you can also look for JavaScript calls, AJAX calls. A lot of times especially in modern web applications that are, JavaScript single-page applications, when you perform an action, you may not see what's going on behind the scenes. It's not reloading a page. It's not doing anything like that. So if you, pop open that developer console down there and see what those AJAX requests are that it's making, If those aren't protected correctly, and you're not checking permissions every single time on that, basically you can take that and replay it or modify it slightly. How many people are familiar with a capturing proxy? Okay, cool. All right, most folks. Zap has this built in, Burp Suite has this built in, to where you can basically have it be the between your browser and the service. So you capture that information, modify it slightly, and send it on. You can also do something similar with the Chrome developer tools, and I think Firefox has something similar. How many people knew you could right-click in the developer tools on Chrome and copy it as a curl command? Yeah? Okay. That's super handy, by the way, because it captures all the cookies, it captures all the session information that the browser has access to, so you don't have to recreate all that stuff in your scripts. You can just tweak that information a little bit, and it's all command line, which is super great. Like I said, implement those consistent access checks. Another thing that's easy to forget is checking access on the data level. Because sometimes what will happen is you'll go to one page and you can view, you're limited on what you can view on that page. But then you go to another page and it pulls more information and you're just assuming that the access level is the same, and so they actually have more content over here than they did over here, but because you're not checking the data access and the data permissions. Does that make sense? I know. So it's a lot harder to do it at the data level, unfortunately, because a lot of times that means going into the data itself and running it through a filter or something like that. But if it's sensitive enough data and you want to protect it adequately, then you kind of have to do that. A lot of times it is based on the access level of the actual endpoint that's being used. But sometimes it's a little bit different, especially on an AJAX call that's returning JSON, something like that, like a JSON structure of something. Because with ORMs and helpful functionality like that, it's super easy to just say, select all this information and then spit out all that information. And if you're not filtering it based on what you need to, then you could be exposing a lot more than you should. Like I said, consider the use of public IDs, such as UUIDs. A lot of times that'll involve storing that information right alongside whatever the record is. There are some systems out there, and I forget what it's called. There's a library or a method where you can put in an ID or one or two pieces of information, and it'll spit back out essentially a stub value. And it's consistent so that you can take that and reverse it back. Not base 64, but it's slightly different than that, so that you can kind of reuse that. And it's not 1, 2, 3, 4, or 5, that kind of thing. All right, general information exposure. You find those secret values, whether it's incremented file names. If you upload a file on your service and you change the file name or do anything to make it a little more standardized, you have to be really careful with that, because if you're introducing sequential numbers or sequential values or anything like that, then you could potentially make it a lot easier for an attacker to just say, oh, well, I'm just going to start guessing file names. What I usually recommend for file uploads is having it pass through an intermediary script. And then what you can do in that intermediary script is you read in the file, you check the current user in the session to see if they have the permissions they need, and then you basically just stream the file contents back out. So it might be file upload view, and then the file name is a parameter, and then it can actually filter and check those permissions, rather than having them be directly web accessible. You can use this kind of thing to gather intelligence about the different targets while you're testing. If your application has a robots.txt, that's pretty popular for defining rules for search engines and everything. You have to be really careful that that doesn't also expose other things in your application. Obviously, most normal people are not even going to even bother with looking at that robots.txt. But if you're saying disallow, certain directories, keeping the search engines from reaching it, that could provide information to an attacker or to you as you're running, your tests on the application. So you can find it like hidden files, like robots.txt. Sometimes what you can do is you can actually cause errors on purpose. Like if you know that something's looking for a certain type of input, then go ahead and send it the wrong type of input. Send if it's looking for numbers or if it's looking for certain characters or something like that. Send it bad data. Send it random ASCII characters and see what happens, because sometimes the error messages will actually expose information that you don't want shown to the user. It's really easy to just say, okay, capture this exception and then take that that error message and spit it out to the user. Well, if you're not catching all those exceptions correctly, then the message they see, like PHP loves to do on its default exception handling, is actually a full stack trace of what just happened in the application. So you get file numbers, file names, class names, lines that it executed on. There's lots of information. So if you cause errors on purpose, you might get information like that. And sometimes it's not even the application that it happens at. Sometimes it can happen at the server level as well. So it just depends on how they have it configured. And then sometimes, if you're really lucky, you'll find a code injection, and you can use that to expose environment variables. Environment variables is a pretty popular method for protecting sensitive values in web applications. If they're able to inject any kind of code or run anything on the system, then the chances of them finding those environment variables goes way, way up. So you have to be really careful with those as well. Don't put super sensitive stuff in those environment variables. Some of the fixes: avoid security through obscurity. Ensure that anything that's output to the users is clean, that you're not exposing too much information. If you have error messaging in your application, be sure that it's not just catching exceptions and relaying it. Everything should be some kind of a custom message that's shown back out to the user. You should never rely on something that your language, whatever it may be, happens to spit back out. And sometimes I've seen people even go to an extreme and say, the message just says there was an error, and then there's a code after it. And then they have to go look up the code. Either the user has to go look up the code, or they call customer support and say, I got an error, it has this code on it, and it's extra hassle. Don't try to do that. That's more pain than it's worth. Just make it contextual, but make it custom defined instead of language output. And if possible, avoid the use of direct column names and identifiers in user-facing content. This kind of stuff is really easy to do on like data tables or something like that, where the column name might be in the query. And then that just gives them information. Then they can start modifying that. You have the sort on the actual data table, so you can sort it by AJAX requests. You could be potentially exposing basically every single column name in that particular table. So you have to be very careful with that kind of stuff. So just look for that and see if there's some way on your back end that you can kind of capture that stuff and say this column corresponds to this, this particular, or this value corresponds to this particular column in the database. So you're not showing those directly. Okay, cool, awesome. I do get to give the examples. Okay, so like I said, normally in the tutorial session, this is the point where we would just start on the application, and everybody would get to hack away at it and try to find the issues. We're going to do this as a group, so hopefully everybody's not asleep from their lunch. Everybody wake up, kind of get going. Okay. All right. No cheating. Okay. Hey, it's me. So let's make this full screen. And a lot bigger. Whoa. Okay. All right. So these challenges are going to be based on the stuff that I just went over and any kind of knowledge you might have about the OWASP Top 10. There's a couple of things in here that maybe I didn't talk about specifically, but they're in general good for a developer to know. What we'll do is I'll actually go through the challenge, I'll walk through the challenge with you guys after y'all try to guess, basically. And then explain, how that could be fixed on the back end. I wrote this in PHP. That's my background. So it's relatively simple application. So I can show you the code. It should make pretty much sense, even if you don't know PHP. So anyway, all right. So first up, let me make this a little smaller. Okay. So if this was your application, what would you do? How would you start testing this?
View source.
What's that?
Right-click view
Right-click View Source. So let's see what happens when we do that. View Page Source. All right. Anything looking suspicious? I'll go a little faster because reasons. Anybody notice anything? /admin. Yeah, look at that. Somebody thought that just commenting out the link would be enough to protect the admin page. Security through obscurity. Yeah. In case you're wondering, yes, it is not. So if we go to the admin page, that's unprotected admin direct access. So obviously, you would want this to have some kind of protection around it. This does have a username and password on it, which is good, but you would still want to block this if you don't want normal users to be able to access that. You can do it at the server level and actually have a configuration, Apache or Nginx or something like that. You can have that in the configuration to say this URL in particular, the /admin, can only be accessed from inside of our network, something like that. When you're protecting your applications, don't just think about protections at the code level. Think about protections at the web server level, at the network access level. I don't know how many people are basically a development group of one. Okay, here's a couple of you. Well, hopefully you have a couple of other folks, around you, maybe even a DevOps group or, some other networking group that can go in and help you set that kind of stuff up. But, don't forget that there's other layers of protection, that kind of idea of defense in depth, so you're not just adding one layer of protection on your application. Got that pretty quick. Good job. All right. Second challenge. I might have to look at my notes. I'm trying to remember this one. You want to start off with a view source? Anything interesting in there?
What's that drop down? Is that just the
header? That's the header for the, yeah. Don't worry about the stuff for this. This is just. Anybody have any ideas? Nothing really interesting in the source. JavaScript console? All right. Let's take a look. I didn't see any JavaScript in there, but we can take a look. Console, reload. Nope, nothing in the console. Network traffic. Page, CSS, JavaScript. There's the PHP session ID, and that's it. That's auto-generated. So you know it at least started a session. But think about other things that you could look at. I mentioned some secret things you might be able to look at.
Are there hidden fields?
There are not hidden fields, no.
Headers?
No, not headers. Wait, that's a good guess, though. You can take a look at those. If I can, this is really hard to do on this little podium. So if we reload this, that is so tiny. I wish you could actually increase the size, but no, there is not anything special in the headers. But that's a good guess. Robots.txt? But who would do anything bad in there? See anything? Anybody want to shout it out? Files, yes. So if we go to that files directory, what do we get? Now keep in mind, this was kind of a capture the flag thing. So the first thing everybody went for was the flag.txt, which, So then there's a log, and some people went for the photo. I actually had somebody, whenever I was doing this, take this and try to like look at the header information and what is it, steganography or whatever? I forget what it is. Yeah, they actually tried to reverse it that way. I was like, you're trying too hard. Okay, so this last one. Let me make this bigger. I'm going to close this. Okay, so this is a random log file that somebody left in that files directory because they forgot about it. Notice anything? Admin passwords, yes. All right, so what else does this show us that we didn't have information about before?
Path, login.
The which one?
The login path.
The login path, yep. User login. You can see it on each one of those. So if we go back to our application here, user login. Oh, there it is. We log in with those credentials. Oops, I guess admin would be better, huh? Yay, we found the flag. Our happy little flag spaceman. Good. Good, good, good. See, you guys have got the hang of this. I don't know why you're even in this session. All right. So we're back to the blog. We have some functionality here. This one's not directly obvious. Let's just say that. It's not on this page. I will give you that hint. So where should you start looking? The source? You want to view the source? Oops. All right. So let's look here. Make this a little bigger. Let's get past the nav there. So you've got some links. It doesn't look like there's anything particularly interesting in there. So let's see. What's next?
Can you open the source up again, actually?
Yep.
The views, those had I couldn't tell if those were hyperlinks or not. Href, so maybe trying view 4 or just /view.
Okay. So let me, oops. So you're saying view 4, like that. So there's no content, but also no error messages. Page not found, which is pretty much expected, but there's not really any useful information there. We can even view the source on that and see that there's not any like hidden information. So, any ideas? Okay, I like where you're going. Put it in the comments field. You like my little memes there? I love that dancing Spider-Man. All right, so let's try putting in our traditional, oh, I guess I can look over here, huh? Our traditional script tag. So if we do that, we get a lovely message that says JavaScript is not allowed. So we can't put direct scripts in there. So what's next to try? What's that? No, this is not SQL injection, I'll say that. You were getting close with the cross-site scripting.
Do you HTML code it in the text box?
Oh, no, that would just, so whenever it outputs it, it actually templates the output, yeah. So think about some other ways that you can get JavaScript into a page besides script tags. In a what now? Yes, in an image. So if you do, something like that, I think that'll work. I might have to review my notes. So if we do that, then we have our image down here. Oh, I think it's broken because I didn't quote it correctly. Hang on. So now we have a pop-up. Very good. So how many people knew that you could do those kind of on-error, on-load, all that kind of stuff inside of image tags? That's yet another vector. So it's really hard to prevent that kind of stuff if you're not just doing strict output escaping. That, obviously, that's going to be fixed. If I escape the output on this, then that image tag is not going to be displayed as an image tag. It's going to be displayed as that literal HTML value. Does that make sense? So you kind of have to think not just about script tags or anything like that. There's also a possibility for JavaScript injection, where they're injecting a dynamic value into a JavaScript string that's on your page if you're using that directly in your JavaScript. Yet another reason to have your JavaScript in external files, separate files, and not defined directly in the page. Is anybody here using a CSP, content security policy? Do you have local eval turned on?
Yes. Unfortunately, for Den, it's a POC at the moment, so.
Oh, okay. All right. Well, that makes me feel a bit better. So the content security policy lets you define what JavaScript can be loaded on the page, what images can be loaded on the page. It's sent as a header, so that's automatic. It's not something you have to include in the body of the site. But one of the switches you can turn on and off for JavaScript is allowing local eval, basically local JavaScript executing in the page that's written on the page versus in another JavaScript file. Ideally, you need to get to the point where that's turned off so that you don't have any script that's not defined in a JavaScript file somewhere. Because that allows you to keep issues like that, injection issues, out of your JavaScript directly in the page. I know it's inconvenient sometimes when you have those dynamic values and you want to put it into that JavaScript. So you kind of have to work around that a little bit and have it pull from like a hidden value or pull something from a session, or it just depends on how you want to do it. But abstracting that JavaScript out is always a better idea. How are we doing on time? Okay, doing pretty good. All right, challenge 4. So we are given a username and password. This is the login for your application. SQL injection? Hang on, let me check my notes here and see if I have. Sorry, don't look. Oh, crap, how can I turn off mirroring? Hang on. I'll block the... There, okay. Now you can't see it. Oh, can I turn that off? Use a separate display. There we go. All right, now, where is my browser? There we go. This will be easier. Make that bigger. Okay. So now let me get my cheat sheet up here. This is 3. Okay, I will tell you that this is not a SQL injection issue. No, I don't want my contacts there. So this is actually valid functionality that's, I almost said it. It's not an error, no. So I will give you a hint. I have a valid user login. And there are other valid users of the system, as listed here.
Default creds?
Default creds for which one? Admin. So it's actually multiple things in this one. But yes, default credentials. Everybody's installed software or they've installed an appliance or something like that. It's a huge problem. People leave those default credentials out there. If you want to see how big of a problem it is, go and search for the software that you're using or the hardware that you're using and search for default login. There are tons of sites out there, especially for routers, network tools, all that kind of stuff. They just have all those default passwords. And so if you leave those default passwords, you're basically leaving an open door to an attacker. So be sure, and especially make them robust passwords. Once you change them, don't make it admin1 instead of admin, because that's super easy to guess. Okay, so there's actually something else here. What changed between my user that's not an admin and the admin user?
The capability to add and delete.
Okay, all right. So let's do, I'll open those just for use later. Okay, so if this was your application, how would you investigate what was happening here?
Need a proxy to see what the delete button.
What's a simpler way? You can look at the URL. But yes, you can inspect the element and actually get that information. So when that runs, so we'll delete our test one. Let me add another user here. I think this is, unfortunately, this is going to be the last example I can get to, but we'll just do test, test, test. Save that user. Okay. So we can delete this user using that address, right? So if you can't read that, that's /challenge/challenge4 delete 9. So when we go in and do that, user is deleted successfully. So what should we try?
Your user.
My user. Test. Okay, so we don't have the delete button. So what are we going to do? Try to delete anyway. So let's try, I think it's 8. User deleted successfully. Permissions are not being checked on the user delete correctly. That's why I re-emphasize the fact that you need to check those permissions on every operation so you're not assuming from the session that they can do that, especially on damaging things like this. Deleting, updating, anything like that, always check those permissions every single time. So, okay, I unfortunately am not going to get a chance to go through all of my examples, but hopefully that was useful for you guys. I do want to mention some basic tools. Oops, too fast. I mentioned SQL map already. That's super great for abusing SQL injection if you happen to find it. Kali Linux is super useful. It's actually a full Linux distribution that comes with a lot of these tools already built in. And you can get it as an image. I think they might even do a Docker container now, something like that. But you can go in, and there's tons more besides just web application stuff. There's lots of other tools in here. Completely free, so you can download it, run it in a VM, and go poke around. John the Ripper is good for reversing hashes. Does anybody know why you shouldn't use MD5 hashes and SHA-1 hashes?
Broken.
What's that?
They're broken.
They are broken, but what's a super easy way to find out what? Even easier than that. Even easier than a dictionary attack. Anybody? Google search. Yes, you can Google MD5 hashes and SHA-1 hashes and get the plain text string. You don't even have to reverse the hash itself. So don't use any of that. And then the Beef project is a good one for just general exploit. It actually runs as a browser integration thing. And so it does the testing as if it was a user, or runs the tests as a user would through the browser, instead of trying to do an automated test where you have to have it log in and do all this other stuff. So, all right. Well, that is all I have. If anybody's interested in seeing the other things, there's a fun serialized injection one. There's a JWT injection, or bypass, and I think that might be it for that. But anyway, that's me on Twitter, Enigma. I'm usually tweeting about random stuff. Sometimes it's security, sometimes it's not. And then I write articles for this websec.io site that I started a while back. A lot of it's kind of PHP focused, but there's some general security stuff in there as well. So if you want to check it out, I would appreciate it. Any questions, comments, thoughts? Yes?
Is that the software that you have, is it available online?
Which one?
The one that you were showing us?
Not currently, no. Well, it might be a public repo. I'm not sure. I'll check on that.
Okay.
Yeah, come up after and I'll take a look at it. Yeah. Mm-hmm. Anybody else? No questions? Did you all fall asleep? Everybody, yeah? After lunch, Okay. All right, well, if nobody has anything else, thank you for coming. Appreciate it.